Go to Camino, California. Art's turn, west of the Rockies. Hello, Art, go ahead.
Gentlemen,
yes.
There seems to be more and more compelling evidence that there are solar systems with planets.
Absolutely.
Which is pretty exciting. I'm a wildlife biologist, and we, of course, use relatively small samples to extrapolate wildlife behavior and populations. Now, okay, we have one tiny sample here, Earth and our sun. Is it reasonable to extrapolate that out to the many hundreds, thousands, billions perhaps, of other solar systems with planets that could possibly contain life?
I guess depending on which direction you want to go with when you mean to extrapolate out, I think the answer to that could be both yes and no. I think absolutely yes from the point of view of the diversity and sheer number of systems that we already know are out there. It's not even speculation at this point anymore. Through ground-based observations, and now especially the Kepler mission, as we discussed earlier, as you pointed out, we know decisively that there are just thousands and thousands of other specifically known systems, and then you extrapolate those numbers through the rest of the galaxy, and it literally is just billions of other planetary systems in our galaxy alone. And then if you want to then extrapolate to the properties of what extant life might be on these other systems, that's where we get into a more fuzzy situation, because as a wildlife biologist, you know full well that the evolution of life on a planet is a pretty the natural selection forces that push you into one design versus another and so on. There's certainly convergent evolution, but boy, I don't think we're going to find anything in the galaxy even remotely resembling what I think the most bizarre life forms that you can pick from the bottom of the ocean here on the Earth are probably much more familiar than anything we're going to find in other systems out there. It's the universe is far more imaginative than we are, and I suspect that there's going to be some stuff out there biologically that would just absolutely confound us if we were presented with this. That's the beauty and the majesty of it. I think there's just so much out there waiting to be discovered. It's awesome in the original real meaning of the word awe.
Well, Daniel, this planet is of course teeming with life. I mean, it's absolutely stunning.
It's hard to go anywhere on this planet where there's not life. From our perspective, macroscopically, we look around and okay, rainforest. Oh yeah, there's lots of life. But then you go to the Atacama, where it's a very dry thing, and it's like, oh, it's just a lifeless place. But that's our biased opinion as these big macroscopic animals. There's practically no place you can go on the planet and not find it's a bacteria planet. You go kilometers down deep into the crust of the Earth, and we've pulled up rocks that have got bacteria living in the cracks in the rock from kilometers down. So it's a biologically jam-packed planet, and that at least from this one example we have, that seems to just be a natural property of life itself that wants to find and exploit every little possible niche it possibly can. And if that's a universal property of life, then I think pretty much any planet that we find out there that has got life on it will be packed with life, if it's got to that point at all.
Well, let's go to Henderson, North Carolina. Colleen, thank you for calling. Go ahead.
George.
Hi.
Hi, Daniel. Thank you for taking my call.
You are welcome.
This is one of my favorite subjects, and I'll take my answer off the air.
Okay.
That with all the different space debris that we have rotating around our planet, I know that there are some different theories that the sun itself can affect asteroids. Well, how about our space debris? Can it start pulling asteroids in as well? Because I know that the moon itself is being slowly pushed away, from our planet because of what we have out there, and we keep putting more and more up every day.
There's almost 20,000 objects, they said.
Oh, at least.
Larger than 10 centimeters.
Oh, I know. From the size from a little screw up to, you know, the everything else orbiting up there. And I'm wondering if it really could pull, you know, asteroids in. If they get near enough to the space debris,
oh, you just said it's pushing the moon out.
Secondary gravitational field.
Interesting question.
Well, yeah, absolutely. There's, I mean, I think, you know, close passages of asteroids by the Earth will affect the debris in orbit around the Earth as well. There'll certainly be a perturbation there. There are a lot of folks really worried about the you know, the sort of the space debris problem that we have created ourselves in orbit around the Earth itself. Every satellite we launch up there is a potential source of bad stuff to affect other satellites. Paint flecks, fragments from explosive, you know, pyrotechnic bolts that separate stages of spacecraft and the bits and pieces. Collisions between spacecraft, either accidental or on purpose, create debris. And some folks are worried that we are going to be soon approaching a stage where we hit a sort of a runaway cascade of collision debris that will be very difficult to clean up once it actually starts. The atmosphere itself of the Earth itself is probably the very best cleaner we have for low Earth orbit, at least. What we think of as the vacuum of space orbiting in low Earth, in the low Earth environment, where the space shuttle flew, where the space station flies, where Hubble is right now, as we discussed. It's not the pure vacuum that we normally think of. There's still enough distended atmosphere up there that it causes a drag over time and causes this stuff to, over the years and decades, to spiral inward. So, in a sense, there's a natural cleaning mechanism. Where we're most worried about are the higher Earth orbit positions where that debris doesn't get naturally cleaned out. You mentioned sunlight effects. That's a very good point, because in fact, what we have learned about the effects of sunlight on asteroids changing their orbits over time, we learned how that works from actually observing the effects of sunlight altering the orbits of artificial satellites in low Earth orbit. And so, in fact, it is true that sunlight is a perturbing effect on some of this debris and does affect its orbit.
Let's go to Stoughton, Wisconsin. Brent is with us. Hey, Brent, thank you.
Aha, you took me by surprise. Glad to meet you there. Glad to talk with you there, George and Daniel. I've got a theory here I would like to present to you.
Okay.
Right.
Is it possible that
nice greenhouse.
Another galaxy can collide with another galaxy?
We see it not only possible, we see it all the time.
Seriously?
There are beautiful,
we've
talked about Hubble and some of the amazing observations and new things we've learned from Hubble observations. Hubble has presented us with some of the best images of the after effects and the ongoing process of collisions between galaxies. It's a very common thing, because galaxies actually tend to live in clusters with each other.
Isn't Andromeda coming this way, Daniel?
I'm sorry? Yes, Andromeda.
We're in the process of being collided right now.
Our own Milky Way galaxy is destined for a collision with the other large galaxy in our little local group of galaxies.
And I'm sure time is up, right? Yeah, time has been up.